Hi, I'm Steve Wernke. I'm a professor of anthropology, and I direct the Spatial Analysis Research Lab and the Vanderbilt Initiative for Interdisciplinary Geospatial Research at Vanderbilt. And so at this point in this project, you may be wondering sort of how you get the data that you've collected on yourself, your tracking data on your phone, into a format that enables you to see yourself kind of from above, like this picture that you're seeing. This is my desktop background. How do you get it into a map view of the world? And so, as you can see on this image that you're looking at, it's a kind of a strange view of the world. Actually, it's an unnatural view of the world. I'd never be able to see this site from this vantage if not for a drone or a hot air balloon. This was taken with a drone. But it's also kind of a privileged perspective on the world in a sense, or it's a very a particular kind of vantage on the world, in that it enables you to see the world and space from above in ways that you simply cannot from a subject-oriented position on the ground. You might be able to see spatial relationships from above, and you can see across vast areas and see kind of spatial relationships at different scales in ways that are not possible from the subject position on the ground. So how do we get to this perspective? How do you get your data that ends up looking like this, right? Which is just a bunch of text, right? You've done a little bit of transformation of your data to get it to look like this, right? And it's just text, it's just numbers in a text file. This is actually my tracking data. An X and a Y here. These are the key locational coordinates, of course, right? But what does it negative 86.78 blah 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 mean? And what does Y equals 36.122 blah 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 mean, right? What do those coordinates actually mean, and how do you get it on the map? So it turns out that those are actually angular measurements. We're used to thinking about coordinates as kind of a grid of equal measurements divided up by units of measure in linear measurements, right? But these are actually angular units. But angles of what? So it's kind of interesting, actually. So latitude and longitude are angles relative to a central point in a model of the actual shape of the Earth, right? So you have a model of the shape of the Earth, a kind of a globe, an abstract globe that is a spheroid, right? The Earth is not a perfect sphere. It's flattened on the poles. So we call it an oblate spheroid. Now, none of these models are perfect. They're models, right? Because they're shrunken way down. They can't account for every irregularity in the shape, but they're pretty close, right? So you've got a theoretical center point in that model. Well, you have an actual center point in the model, but the model is theoretical. And then these angular units are relative to the meridians that are lines, abstract lines that divide up this globe. Meridians run north-south through the poles and then converge on the poles, and parallels, which run parallel horizontally across and around the globe here. So, for your east-west measurements, you're using these vertical lines, right? These meridians. Now, in this case, where they're plotting, this is a nice a model from ESRI, which makes ArcGIS, which is the most widely used geographic information system software out there. So in this case, they're plotting this point at 50 degrees east and 40 degrees north. So 50 degrees east relative to what? Relative to this zero meridian, what's called the prime meridian, that runs through Greenwich, England, just as that's where this system developed. And this is, geographically speaking, what divides the eastern hemisphere from the western hemisphere, right? So that's our zero line here, and we go 50 degrees east and then this point is at also 40 degrees north. And our zero line on this axis, relative to our parallels, is our zero line is the equator itself, right? So that's a little bit less arbitrary, right? In the sense that there is an equator relative to the spin of the Earth at its poles. It's the widest point of the Earth. Okay, so then you've got 50 degrees east, 40 degrees north. You can plot any point on the globe with just those two pieces of information, of course. Very efficient way to plot location, you know, and it's no accident that this runs through Greenwich, England. I mean, these systems emerged from the Renaissance, when Europeans first became kind of dimly aware of the actual shape of the Earth, as Europeans expanded beyond Europe and the monarchies established colonies and invaded the lands of Africa, South Asia, and the Americas. Right, so there's a power in coordinate systems that's literally enabled, you know, imperialism and colonialism, and there's a power in how this efficient data model works to record data on you, whether you're recording it yourself or an outside entity is recording it on you, so that they can plot you in this map's eye view or bird's eye view of the world, right? So here's that same data set that I just showed you from that perspective, right? It's just XY data. Let me zoom to the proper scale here of my tracking data over 4 or 5 days. And it's just a series of points, right? So now we can see it. At least we can see it as a flat projection on the screen. This is the default kind of projection that most modern computer systems originates literally from the Renaissance. It's the Mercator projection. And there's some readings that I'll link to about the Mercator projection. But it's literally a 16th century invention that these modern computer systems that reproject that raw coordinate angular data into a flat XY coordinate system that is in fact on a XY distance-based grid, right? A Cartesian grid that way. Okay, so we've got our points here. Can't really say much though, right? It's just the points. So the key thing here is to think about the points in relation to what other data you might have. And so, you know, here's just a start, right? Just here's a base map. Now, the things to think about are, you know, at what scale do you move? And how does that affect your perspective on the world? What are your habitual routes? What are your habitual daily rounds that you make? How does that affect your perspective on the world? So in this case, it's about 4 or 5 days of my data. This is COVID time, so I'm not moving around a lot. I mean, if I zoom out, you can see it's all contained within really a pretty small area of Nashville, right? Tennessee. If I zoom in a little bit closer, you can start to make out perhaps where I'm spending more time, because you just see a lot more points. And it turns out, well, here's my house. And here's where I walk my dog, right? I went for a bike ride with my daughter, who just learned to ride her bike, and she took me down this little path by this school that I would have never done by myself. So there's this interesting little personal geography here of going for a bike ride. I go for runs every so often, so I've got a bunch of runs in here that are kind of overlapping. Actually, this is a run that runs out over the river and into East Nashville and back. That was my long run that weekend. But, you know, I spend a lot of time here. I spend a lot of time here on Vanderbilt's campus. And the rest is kind of transitory, right? And so what are the opportunities for my interactions with others, with my interactions with the built environment, the cityscape itself? So here we could start to build in other layers, like here's Nashville's wealthiest zip codes, right? So dark green here is really wealthy, top 25%. The lighter green is 26 to 50th percentile, and gray is lower percentiles, right? So, you know, I'm living in a pretty affluent area, right? So a lot of my daily rounds takes place in this kind of bubble here between here and campus. Let me zoom back out. So here's campus out here. Now, sort of my run brought me into more socioeconomically diverse, I would say, areas. That's interesting. That starts to be interesting. But if I zoom way out, you can see that now this is Nashville, greater Nashville metro stuff, but you can basically see, you know, this is a pretty affluent area of this metro area. So zooming in and out and thinking about your propinquity for interaction with different kinds of environments, right? Here's building permits as another layer, right? Building permits, you know, here's just a bunch of point data, and I could create a continuous surface of these building permits. Why are building permits interesting? Well, it's kind of a proxy for economic activity more generally. So you would expect more building permits where you have like gentrification happening, new businesses, building new buildings, that sort of thing, right? So I could interpolate this into a surface, a heat map of building permits. So, you know, central Nashville is undergoing a lot of building. And you have these outliers where these are economic hotspots out here. But basically, a lot of my activity is going on in the most economically kind of active part of Nashville. So that, of course, is going to have an effect on my perspective on the world. And I can make a heat map of my own movement, right? Here's an example of that. Here's a heat map of my movement. We could overlay those on top of each other. Looks like that. So I'm spending an awful lot of time in urban Nashville and gentrified Nashville, let's say, right? So that's just an example of how you can start to intersect your data, your movement data, with these other kinds of data, and then you can start to think about, how do you look then from above? How do you look from the outsider's perspective, from the map perspective? How might you look from these outside entities' perspectives? So the basics of that process of how to get your data are described in the other video on this page, and it will set you on that course to start exploring your personal geography in that sense.